So this is the 4.3 number 3 homework solutions. So I'm just going to go through a problem in each section. So for example, in the first part, for number 15, we're asked to find the definite integral of the graph. So we have to write this out as a definite integral. So we can see the area, we're taking the area under the curve from -4 to 4. So on our definite integral, a is -4, b is 4, and then we're taking it of our function 4 minus the absolute value of x with respect to x. So that is why the answer to 15 is what we have there. And then we can move on to the next part. So I'm going to do number 31. So we have the area under the curve of the square root of 49 minus x squared, and we're taking the definite integral of that from -7 to 7. So the area under the curve is a semicircle. So the area of a semicircle is 1/2 pi r squared. And when we plug 7 in, it's 49 pi over 2. And that is our answer to number 31. So now we can move on to the next part. So we can go to number 36. And for this one, we don't really need to know how to solve a definite integral. We're just applying the properties of definite integrals. So we can take -3 out, and we can take the definite integral from 2 to 6 of x with respect to x. So we know that the definite integral from 2 to 6 of x is 16. So when we multiply 16 by -3, we get -48, and that is our answer. Okay, so now let's move on to question 41. So for this one, we have the definite integral from 0 to 7 of f of x. So using the properties of definite integrals, we can take the definite integral from 0 to 5 of f of x and add it to the definite integral from 5 to 7 of f of x. So we have those up there, the values, so we can add 10 to 3, and we can get our answer is 13. So for number 47, we're just taking the definite integrals of different parts of the graph, and it is the same function. So the answers are there. I'm just going to skip this one. Okay, so let's go on to 51. And we're asked, we have the function, and we're just going to apply the function in the definite integral, and we're going to find the area under the curve. So f of x is 4 when x is less than 4. So to graph y equals 4, that's just a straight line right here. And then when x is greater than 4, y equals x. So that's right here. And we have to find the area under this curve. So we can see it's made up of a rectangle, a different rectangle, and a triangle. So once we find those areas, we can just add them together, and our answer is 40. Okay, so for the last section, I'm going to do part 61. So for this part, we can graph out the function sine of x, and when the area is less than 0 is when, right here, for example, there can be definitely more values when sine of x is less than 0, but when a is pi and b is 2 pi, the graph is under the x-axis. So an example value of that would be a is pi and b is 2 pi. So that's an example answer for that problem. So yeah, that's all the solutions, and I hope this helped.